My name is Brian Slayman. I'm a product line manager for EnGenius Technologies. I want to thank Streakway for hosting today's webinar, and I want to thank everybody for joining today. We appreciate your time and interest. Today's topic is our security access points, the ECW230S and the ECW220S, which come with our latest feature, which is called AirGuard, a wireless security solution. But these access points come with additional benefits. And pardon me for a second, I clear my. We'll cover all these different, the security solution part and also the additional benefits. I'll cover that in today's webinar. So with that said, let me go ahead and get started. So what I'll discuss today are threats, things that we're seeing in the industry, what we experience probably on a daily basis. We'll also talk about the EnGenius AirGuard solution, which is our wireless LAN security feature that was just added about a month ago or so. Then we'll go into advanced tools. These advanced tools can only be found on the ECW230S and the ECW220S. And then we'll go into the hardware and talk about the hardware spec. There's two form factors, and we'll discuss those. Then we'll go into a Q&A. And then, as Angela was mentioning, we are raffling off the ECW220S. So you'll learn more about the 220S and the 230S in these following slides. So we'll raffle 10 of those off. So good luck to everybody. Just stay tuned. Okay, so what are the threats? So I think everyone installing Wi-Fi is experiencing this. Secure Wi-Fi access is really a critical component for really any enterprise network or any network just in general. So data transmitted over wireless contains, sensitive information such as personal information and financial information. The real concern is all of the open source hacking tools that are very easy to get. And attackers can use these tools to basically steal credentials. They can even inject malicious code into victims' browsers. They can redirect the victim to a malware site, for example. They can do this through really two main methods that we're looking at. And that's impersonating client devices or an access point, or like a rogue client device or a rogue access point. So we'll talk a little more about that. You can find new data breaches and attacks in the news almost on a daily basis. One of the entry points for an attack is a rogue device, like I mentioned before, like a rogue access point, a rogue client device. Rogue devices, such as an access point, can be a gateway to many breaches and or attacks. So the industries most vulnerable to hacking are retail, finance, healthcare, education, warehousing, airports and rail stations, government, and distributed enterprise networks. Ironically, you'll find a lot of rogue APs in more enterprise spaces where employees are bringing in access points and they're blindly connecting them to the LAN port, leaving the access point or wireless router open with no security, where anybody could access that network at any time. So you do see a lot of rogue AP devices in enterprise spaces. You'll find a lot of attacks happening on the retail, where they're offering free Wi-Fi and users are blindly logging into SSIDs or broadcast names to get Wi-Fi access, and they're logging into a rogue device. So there's plenty of news out there in regards to the number of different attacks and breaches that are happening in today's news and the different industries. So that introduces EnGenius's AirGuard system. The EnGenius AirGuard is our launch into protecting wireless and wired LAN networks. And you'll see a significant development with this particular solution and others in the near future. Some may be aware, some may not be aware. We will have a security gateway coming in the near future. So keep an eye out on that. So there's a lot of development, significant development around different devices like security access points, which we're talking about today, and a security gateway that will be coming soon. So this is an introduction to EnGenius AirGuard. So the AirGuard solution is a Cloud Pro feature. The AirGuard system is an automatic system that allows network administrators to meet the requirements and design a network architecture that provides an industry-leading security platform in order to completely protect the airspace from wireless attacks. So we want to protect ourselves from rogue SSIDs, evil twin attacks, RF jamming, and a number of different things. So this is our method of providing those WIDs and WIPs technology within the cloud system that we're offering today. The AirGuard system delivers multiple benefits to administrators. It provides, this is, the first step is detecting, and one of the most important things is providing an automatic detection and protection from Wi-Fi threats, such as like a rogue AP, for example, or an evil twin attack, a malicious attack, or an RF jamming attack. It also will assist in identifying rogue SSIDs to prevent users from connecting to unauthorized devices or access points. And it allows, the system will allow legitimate external APs to operate in the same space as well. So this system, the AirGuard system, first detects. So the AirGuard system will continuously monitor and detect the radio spectrum for the presence of unauthorized rogue access points and wireless threats. And it's doing that through, we have scanning radios built on the ECW230S and the 220S. So it can do this 24/7. And it's using the scanning radios to be able to detect. It then can put it into a category, and putting it into a category is really important to understand what kind of threat it is, and so we can offer advice from there. So the system finds and auto classifies suspicious APs and SSIDs, as well as potential wireless attacks like an evil twin attack or a deauthentication attack or an RF jamming attack. And finally, the system will add some advice to that. The system will send notifications to the admin whenever security issues are found and make recommendations for troubleshooting. Like I said before, this system will evolve over time, and we'll add more and more to the system. So you'll see that coming in this quarter and the following quarter. The AirGuard technology is basically WIPs and WIDs. The system will, like I said, will evolve. You will see more features coming this as close as this quarter. So I think a lot of the customers that we talked to today are very aware of WIDs and WIPs. WIDs are wireless intrusion detection systems. That system monitors the radio spectrum used by wireless LANs for presence of unauthorized devices like a rogue AP, for example, and identifies wireless attack tools and immediately alerts a system administrator when rogue AP is detected. Then you also have WIPs, which is wireless intrusion prevention systems. The system monitors the radio spectrum as well for the presence of unauthorized APs. It can automatically provide countermeasures. It can accurately, the biggest thing is accurately detecting and then automatically classifying a threat. That's the first major step, and that's what we're really providing here with the elimination by the administrator. So prevent the connections between a rogue AP and wireless connection. If you have a rogue AP and a wireless connection, once that connection is made, the threat is, or the attack has already started. So you're kind of too late, but you can take measures to dismantle that from happening. So let's talk about rogue APs or rogue devices, I should say, not specifically APs, but rogue devices. Rogue devices are really the gateway to different types of attacks. You may or may not know what a rogue AP is, but a rogue AP is an access point that is connected to a company's physical network, or it could be just outside of the network, for example, but it's not under the company's administrative control. So somebody's brought in an AP connected to a wired network, or somebody's outside of your building next to your network and broadcasting an SSID for employees to connect to. So an employee or student could bring in a home Wi-Fi router and connected to the company's infrastructure to provide wireless access. And the act introduces multiple threats to the company at that point. So you're broadcasting an SSID with no encryption whatsoever, and then anybody can attach basically to the network. So there's really a couple different scenarios, such as insecure wireless authentication. That's where the rogue AP might only support an older, less secure encryption standard, such as WEP, or even worse, it's configured with no or open association or open access. There's no authentication process on the system in itself, and that's insecure wireless authentication. Another one is inappropriate attachment, a rogue AP that is physically attached to a network port in a secure area of the network, or in an area without a firewall between it and the sensitive information that you're trying to protect. Another one would be inappropriate location. The AP could be placed close to the perimeter of a building, like I mentioned before, or meaning that somebody could listen in on the company's network. There's a lot of times where you may not have coverage in particular areas, and if somebody drives up with a rogue AP or a device acting as a rogue AP, can offer better Wi-Fi signal to the employees, and they may connect to that device, opening up the door for multiple different attacks. So it's really clear that rogue APs are something that we need to be aware of, or rogue devices are something that we need to be aware of to protect wireless LANs and networks in general. Some gateways to threats. Some common ones that we run into are SSID misuse or misconfiguration. When a network AP is misconfigured and does not comply with company security policies, that could be compromised by hackers. That is one that could introduce a multiple problems. So the device is basically acting as like an access point, for example. For man-in-the-middle attacks, when the SSID security type is open, or the WPA, or using WPA personal, the attacker can secretly relay and possibly alter the communication between the access point and the wireless client, who believes they are directly communicating with each other. So there's a multiple ways, but these are typically the gateways into, or when we see breaches or attacks on particular networks. And so we're trying to overcome these things from happening, these threats from happening. So rogue devices or rogue SSIDs lead to threats such as evil twins. AirGuard can detect two types of evil twins. Evil twins are attacks the evil twin attack makes the rogue AP look virtually identical to the legitimate AP. Evil twins are rogue access points that can impersonate a legitimate network, simulating the same SSID and MAC address. So there's two that we can detect. There's AP spoof. This happens probably most of the time, where you can bring in an access point and just rename the broadcast SSID with the same name as the network you're trying to that you're trying to get into. So basically, our SSID here at EnGenius is EnGenius Cloud. And so if I brought in an access point, I could easily just put in the name EnGenius Cloud and broadcast that SSID, and employees could connect to that particular SSID. So AP spoofing is one of those types of attacks that we can detect with AirGuard. The other one is AP impersonation. That's a malicious impersonation of not only just the SSID, but also the BSSID. And the BSSID is the MAC address of the radio that's within the access points. You can do this on 2.4 and 5 gigahertz. So those are even harder to identify, but we can identify the AP spoof and AP impersonation with AirGuard, the AirGuard system that runs on the ECW 230S and ECW 220S. Another thing that we can detect is malicious attacks. You may or may not be aware of denial of service attacks or DOS attacks. DOS attacks could be from a malicious client. It could be from an AP, or it could even be from another WIPS system in a neighboring network. And that WIPS system thinks that your corporate network is a threat, and is attempting, that WIP system will attempt to address that. So it will actually have a DOS attack on your legitimate network. You may or may not be aware, but in communication with wireless access points and client devices, the 802.11 protocol, or the Wi-Fi protocol standard, allows what is called a deauthentication frame to tell a client they have been disconnected from the network. The problem with this process is the protocol does not require this frame to be encrypted in any way. So an attacker can send a deauthentication frame at any time to an access point with a client MAC address, causing the client device to disconnect from the AP. When you do a deauthentication, you're disconnecting your client devices, and so your client devices will want to reconnect. When they reconnect, they could reconnect to that that rogue device, that rogue AP, that rogue client device that's acting as a rogue AP. Now, EnGenius, if you go into one of our systems and you're configuring SSIDs, for example, you can, by default, we have 802.11w enabled. 802.11w is a protected management frame that helps in these DOS attacks. But with older client devices, they can't communicate if 802.11w is enabled. So in some cases, we have to disable that protection. We have to disable 802.11w protected management frame, which opens up the door for deauthentication frame attacks. So we have to be really careful with that. So AirGuard can detect two types of malicious attacks: the deauthentication attack to an AP. The attacker mimics a client by sending an excessive number of deauthentication messages to manage APs and makes the AP disconnect the client. Another one is deauthentication attack to the client. The attacker mimics an AP by sending an excessive number of deauthentication messages to a client associating with a managed AP. This also results in the disconnection of an attacked client. So the objective is to disconnect the clients, maybe just as simple as a prank, but to re-authenticate to a rogue device. So normally these tactics are pretty low key. They don't really require any skills or elaborate equipment. Some deauthentication attacks are innocent pranks on coworkers, friends, even neighbors. So we've seen this happen in residential kind of scenarios. But it can be a component of a bigger issue, such as an evil twin attack, an actual attack. So like I said, AirGuard can detect two types of malicious attacks. Another thing that we detect is RF jamming, or radio frequency jamming. So RF jamming is probably one of the easiest methods of defeating a wireless system. So you can look at it as it's a wireless equivalent of cutting the wires on a traditional wired system, because the Wi-Fi is an open medium and it makes it vulnerable to various attacks. So Wi-Fi jamming sends a lot of noise in the environment, making it impossible for other nodes to send messages through the available channels. So detecting RF jamming is an important item to have within your system. So the AirGuard system, what we've done is we have adopted unique techniques to detect all types of RF jamming while keeping a very low fail rate on the detection itself. And we've continued to develop this system as we've moved forward, and we will continue to do that to make it even better than what it is today. So the system will not easily treat massive transmissions of Wi-Fi data as an RF jamming attack. In contrast, the signal interference sent by a jammer can be efficiently detected in seconds, really. And so we can identify four types. What you'll typically see with RF jammer is major channel utilization, or high channel utilization will be really, really high. So system administrators can use like spectrum analyzers to see who's keeping the channel overworked. But we can detect, AirGuard can detect four, which is constant jammer, deceptive jammer, random jammer, and then reactive jammer. So there's a multiple things that we can do with this particular feature. So once we've identified, classified, what we want to do is be able to have an alert system in place so the AirGuard system can alert the administrator. And we can do this in a number of different ways. We can do this through the cloud interface. If you're currently using cloud today, there's a little bell that's in the upper right-hand corner. Well, it will indicate that there's been an alert. And then you can view your alerts per organization, per network. And it will tell you what types of alerts you're getting, such as rogue SSIDs, evil twins, malicious attacks, RF jamming. So you'll see these through the cloud interface within itself. You will also see alerts on the mobile device. So the Cloud to Go app will also provide alerts if you set it up that way. And then you can also receive them via email. So you can receive these alerts in these 3 different methods. So it keeps track of these alerts and alerts you when something is happening at that current time. So we're detecting, putting them in a category, and then alerting the assist administrator. You'll notice in this one screen, you have the different types of attacks. You'll have rogue SSIDs, evil twins, malicious attacks, and RF jamming, and it will give you some sort of advice. Now, like I said, this system will evolve, and we will do automatic countermeasures. Like we'll actually use DSO attacks to take down rogue APs or rogue client devices. So that's coming in the near future. But this is what we're currently providing today with the AirGuard system. So that was a highlight of one component or one feature of the ECW 230S and ECW 220S, which is the AirGuard solution. These 2 models of access points come with a lot of different benefits, that being one of those benefits, the AirGuard system, but it comes with a number of different advanced tools. One of those advanced tools is zero weight DFS. So let's talk a little bit about zero weight DFS. So if you're deploying Wi-Fi today, you're typically designing around a 5 gigahertz frequency band, not really designing around 2.4, you're really designing around 5 gigahertz. And the most precious thing with 5 gigahertz is that it has a lot of non-overlapping channels, and having clean channels within a Wi-Fi environment is one of the most critical things to have a really good communication to your client devices. If you have DFS channels, that gives you more channels within 5 gigahertz. So you have more to choose from within 5 gigahertz. So the main benefit to using DFS is channels, to increase the number of channels that you have on 5 gigahertz. I would say kind of the issue with DFS, it's reserved for radar. So we have to be really careful when we use DFS channels. So there's a set of channels within 5 gigahertz that also is used for radar. So DFS, or dynamic frequency selection, is a mandate for radio systems operating in the 5 gigahertz band to identify and avoid interference with radar. So that's 802.11h is the standard that covers the usage of DFS. So everybody has to abide by these rules. Every vendor, every manufacturer has to abide by these rules. When you're installing 5 gigahertz devices, you have to abide by these rules. To make use of DFS channels, wireless access points need to be certified first to ensure that Wi-Fi services on the AP follow rules. The best example for that is to stop using those channels when radar is detected. It has to immediately stop. So we find that, installers, system integrators, managed service providers that like to use DFS channels, we actually use it within our office, try to use it because of the less interference. There's more channels. You can do better planning, channel strategies within a large network and so on. So, but however, for an area with occasional radar signal, service providers tend to avoid DFS. So how do we get around that, right? That is zero weight DFS. So zero weight DFS, there's 2 main points I typically talk about. We have to comply with DFS standards. So an access point must perform a channel availability check and wait wait a while before connecting to DFS channels. So this will definitely disrupt a poor and lead to a poor user experience. So we deployed in a university nearby. They had radar and they were having disconnects for the clients. It became, the issue was radar, and it was being detected, so they had to switch off. So there was a disconnection. Well, the ECW230S and the ECW220S use the dedicated radios that are built within those devices to continuously scan all the DFS channels in the background, and it maintains a list of available DFS channels, preventing the clients from being temporarily disconnected and ensuring immediate connection to a new DFS channel. So like I said, the ECW230S and the ECW220S have that scanning radio and provide this feature called zero weight DFS. So just wanted you to make it, be aware of that. Another big benefit to the 220S and 230S is the spectrum analyzer. Before we talk about spectrum analyzer, I wanted to bring up that we already track channel utilization. So we need to keep in mind that we already offer multiple areas to see channel utilization. We first offered a simple channel utilization graph per AP, giving you like indication on 2.4 and 5 gigahertz, which you'll see right here. I use this tool a lot. This is called AP list. I can look at all my APs and it will tell me high channel utilization, or it will tell me channel utilization in a particular area, because I'm looking at a particular access point that's in a particular area, and I can look at the channel utilization and I can see if it's high or low, if I need to make a change to a channel or so on. So I can make those changes here and simply apply. So we're already offering that tool. That tool came out at the launch of cloud. We're now offering, more recently, we launched a tool called Diagnostic Tools, which offers all channel utilization. And this looks at utilization by band. I can actually choose the band to look at channel utilization. I can use 5 gig, or I can look at 5 gigahertz or 2.4 gigahertz. It will measure the Wi-Fi devices and non-Wi-Fi devices and provide you with total utilization. And you can see that within this particular screen. You can even look at it and do a scan and look at different channel widths, the channel number. So 20 megahertz, 40 megahertz on 2.4. I can even look at 5 gigahertz, look at 20 megahertz, 40 megahertz, and we support up to 80 megahertz. And we can look at the different channel and what the channel utilization is. All you have to do is just run your mouse over the particular icon and we'll give you information. For example, Wi-Fi utilization is 18%. Non-Wi-Fi utilization is 1%. Total utilization is about 19%. So, you know, channel 150 or 151, I have no issues in using this particular channel. I think it's fine. You really don't see major issues until you're exceeding maybe 40%, but it's going to be dependent on the number of access points that you have and the area. So you just got to be really careful of that. So we're providing this information to you, but to provide you even more information, more detailed information, we're offering also a spectrum analyzer within the ECW230S and ECW220S. So this is a deeper dive into the RF spectrum. So a spectrum. Hello? Oh, if everybody wants to mute themselves, that'd be great. So with a spectrum analyzer, it measures the magnitude of input signal versus frequency within a full spectrum or frequency range of the instrument. There you go. Okay. So the primary use is to measure basically the power of the spectrum of known and unknown signals. The reason you want to do this is to avoid or to eliminate any interference in a particular area. So, you know, as running a test within our building, we have a break room. Within that break room, we have our microwave. When that microwave runs, you can definitely see the interference on a spectrum analyzer. So, you know, running the spectrum analyzer in specific areas, and you can do that with the 230S and 220S. You can see that an AP is deployed in a particular area, you can measure the spectrum in those particular areas. It's not doing a wide spectrum analysis across the whole environment. You can choose areas. You can focus in on specific areas and run these spectrum analyzers to get an idea of what the radio spectrum or the radio environment is like. So you can do this. So this system allows, it's basically running a spectrogram and a waterfall graph, right? So the top view on the y-axis is the RF channel, and on the y-axis is the power and dBm. The spectrum analyzer is showing real-time and signal strength RSSI detected. The colors indicate how many sources have been detected. The bottom view on the x-axis is the RF channel, and on the y-axis is time. This is basically the bottom portion is the timeline view to let users see which channels are clean or dirtier from Wi-Fi and non-Wi-Fi devices. So the real-time view might show an interference signature from a glance, whereas the time lapse will show interference over longer amounts of time and indicate the source of the interference. So this allows you to make an informative decision and gives you insight into like non-Wi-Fi and Wi-Fi devices. So you may know the client devices that are out there, but you may not know of other interference like measuring devices that are using RF or microwaves, for example, or Bluetooth, or a number of different devices. So it allows you to avoid the interference in a number of different ways. So this is a tool that you can run within the ECW 220S and the ECW 230S. So it's another tool that we're offering within these particular devices. Another thing that we're offering within these two access points, or another benefit, is Bluetooth detection. Now, currently what you'll see with Bluetooth detection on our system right now on the cloud solution, it's supporting BLE5, I should mention that first. But this allows organizations to use APs as basically beacons and sensors that can detect and locate transmitting BLE devices. Right now, we're just giving you a list of BLE devices within the network. And so you can see IoT sensors being detected that can collect various device information and plan wireless networks for the coverage area. You can also, we can provide. Hi, sir, could you mute, please? Or Angela, I don't know if you can mute on your side.
Yep, I got it.
Thanks. The API is, we do have API that's available for third-party integration to provide asset tracking and analytics using battery-based Bluetooth tags or wearables like health fitness monitors and so on. So we've worked with a number of different third-party vendors that track Bluetooth devices. And this access point is one of our first access points, or these two access points is the first to offer BLE. And if you want to take advantage of BLE, feel free to reach out to the Streakwave team if you want more information around this, and we can provide potentially APIs to help with third-party integration. The other usage is location-based targeting, target marketing. The name escapes me, but there's several third-party companies out there that you can actually track devices in retail stores. You can do indoor navigation, Wi-Fi connection, initialization, site location information, advertising services, asset item tracking. There's a number of different things that you can do with location-based targeting, target marketing, I should say. I'm trying to think of the name. If I think of it, I'll mention it later. But this is available also on the 220S and the 230S. So there's a lot that comes with this particular device, or these devices, I should say. So let's talk about hardware. We talked about some high-level features, advantages with the ECW 230 and 220S. So there's two variations, as I mentioned multiple times. These are 802.11ax. One is a 4x4 antenna design. The other is a 2x2 antenna design. They're dual concurrent architecture. The 4x4 design has a 2.5 gigabit Ethernet port. The 2x2 has a 1 gigabit Ethernet port that supports 802.3 AT or PoE+. They're all standardized, so you can use one of our PoE switches or a a standard device. It could be another vendor switch or PoE injector, but it's standardized. They have omnidirectional antennas. As I mentioned before, you can use AirGuard. It has diagnostic tools, including the spectrum analyzer, the channel utilization tool. You have the zero weight DFS. You have BLE5 client list by beacon scans. Obviously, this has a dedicated scanning radio, so it's not utilizing your client radios. It has dedicated scanning radios, so it won't degrade the performance of the device itself. All of our cloud devices come with a 1-year pro license, so you're more than welcome to test the pro features out and make a determination. If I need to use pro in this particular application, I can. If I don't have to use it, but it does come with a 1-year pro feature, or pro license, I should say. So this is it for the ECW 230S and the ECW 220S. So what I'll do is I'll open it up for any questions that you may have, and I'll try to answer those questions. If I can't, I'll circle back with Angela or the Streakwave team and try to follow up with those answers for you. But we can open up for any questions.
Yep, Brian, we had a couple come through, and I'll also leave it open after we answer these that were in the chat. If you guys wanted to unmute yourself at that time to ask personally, you can. This one came in a little bit right after you started presenting. So okay. They said, you mentioned open source, but regardless of source or openness, the common point is something appearing to be your network. Often employees who pretend to be IT. I just want to be clear, you are not calling open source a threat to anyone.
Oh yeah, no, that's correct. I was just saying that you can easily find devices even on Amazon to do like de-authentication attacks. It's just it's open to it's just widely available. I should have said that, maybe is probably the better way to say it. But no, I was not. Yeah, I wasn't saying that specifically. But yeah.
Thank you for clarifying that. And thank you for the question. The next one came in is they're asking, is the zero weight only for the SAP, or will it cover the non-SAPs nearby? Say that the APs that are listed in the SAP's 802.11K report.
It is only for the S versions, the 230S and the 220S. We are developing in the future that may become available within the other units, but currently it's on the 230S and the 220S right now. We're using that extra radio in there to scan for the DFS, the free DFS channels.
Awesome. Next question. Any plans to support Webhook or native Slack pushover support for alerts or notifications?
None on the roadmap right now, but yeah, if you could, Angela, if you could provide my information, I think it might be already available. Feel free to reach out to me, and I can look further into that. We are definitely open for different types of alerts. So that would be great. But currently right now it's not on the roadmap.
Got it. Are these 6 gigahertz ready?
Oh, that's a good question. So Wi-Fi 6E, I think that's what somebody is referencing. So the ECW 336 will be available really, really soon. I plan to set up that particular device, which is a Wi-Fi 6E device. It will operate on 2.4, 5 gigahertz and 6 gigahertz. That will be probably set up the beginning of March. So the setup information will go out. You'll start to see more information about that particular device. And then by the end of March, we'll see units starting to ship. But yeah, great question.
Awesome. There are a couple more. Is there a monthly, yearly fee for the cloud component, and will it continue to work without that component?
Yeah, great question. So that's in reference to the pro license. So the pro license works like this. So you have access point and switch license only for if you're using the pro features. So it's $50 MSRP per year per device. That can be mixed and matched, meaning if I have an access point and a switch within the same network, I could just be operating pro on the access points and basic on the switch, and vice versa if I need to. These access points will work without pro. You just won't be able to use the AirGuard system, the spectrum analyzer, the BLE component. You won't be able to use some of those beneficial pieces to the device. It will work similar to an ECW 230 or an ECW 220. So yeah, they'll work without the pro license, no problem. You just won't get those added features that we just discussed or I covered.
Okay. Next question here. Do all the scanning protection features, the Wi-Fi connection speed take a hit?
No, that is obviously you're using CPU and memory. The main thing to look at though is we've added those scanning radios. So we've the reason for the scanning radios or the extra radios, right, is to do all the heavy lifting in regards to the security side, the DFS scanning. So it alleviates the work from the client radio. That's what I was mentioning before. You have the scanning radios that are doing the AirGuard portion and the DFS, zero weight DFS. While your client radios, the main 2.4 and 5 gigahertz radios, are only for the client. So you won't see major degradation. You might see a little bit because it's using up some memory, some processing power. But yeah, that was our objective to having that other radio. Other vendors, you try to utilize the client radios, which really kills the performance of an access point. So we wanted to get around that and add a scanning radio to it.
Perfect. Is there support for wireless backhaul meshing?
Backhaul meshing. I'm assuming that they're talking or referencing maybe the scanning radios. I think if that's the question, then no, it's not. It's purely for those extra features I was just talking about: spectrum analyzer, zero weight DFS, and AirGuard, the AirGuard system. Meshing is already supported on 2.4 and 5 gigahertz, but you're utilizing those client radios. Just be aware of that. You can disable that and dedicate either 2.4 or 5. The Wi-Fi 6 device is a Triband radio setup, so you will have extra radios in there, and you will be able to use meshing for that particular device, just to give you a heads up on that.
Okay. Next one we have, do you know if there was any redesign of the ceiling mount bracket? I guess it's very hard to cleanly mount a drywall to a drywall.
To drywall, oh. There has been a little discussion, but I don't have anything I could provide today or share today that I can say for sure we'll make a redesign on that. So not currently, no.
Okay. What is the field tested speed with just 1 gig internet and 1 AP?
Say that one more time. I'm not sure if I understood that.
Sure. What is the field tested speed with just 1 gigabit internet and 1 AP?
Field test, actual test, I guess, is the question.
Mm-hmm.
That is hard to say. That's going to be dependent on, I'm sure they're not going to like to hear this, but it's dependent on the client device, what kind of client you're using. Are you using a 1x1, a 2x2? What technology are they using? So there's a number of different kind of scenarios. For me, just with my testing, I have 500 megabit connection. It's symmetrical. It's 500 by 500. I've seen tests close to 480 Wi-Fi tests, but I was within probably 10 feet of the AP. As soon as you get outside of 50 feet, then your speeds obviously come down. You have more interference and so on. So it depends on your environment, your client device. So there's a multiple factors, but I've seen as high as 480 on a 500 ISP connection, and and a gigabit Ethernet connection. So on the AP itself, we'll start to experience above gigabit Wi-Fi Wi-Fi 6E on 6 gigahertz. As long as your client device is on 6E and your APs on 6E, you will see gigabit Wi-Fi. But currently, I've seen as high with customers as high as 800 spikes on average, probably around 600, just to give you an idea.
Great. Are these devices tri-band capable, allowing for a 5 gigahertz wireless backhaul for those applications where a hardwired backhaul is not available?
No, it does. No, it has two primary radios for serving clients. That's 2.45, and then it has the secondary scanning radios. They are specifically designed for the AirGuard system. So yeah, you can't use it as like a tri-band setup. You can't use it as, hey, I have 2 5 gigahertz radios and 1 2.4 gigahertz radios. That's not this device. And for the Wi-Fi 6E device, that's a tri-band setup. That will be a little bit different.
All right. If you mix S and non-S models, will the controller use 0 weight for the entire fleet?
Yeah, so I grasped that on the initial question. Let me think about that. I will have to confirm that. That's a good question. I'm going to say no. It depends, but it depends on the configuration. So you have a choice. You can make, you have radio configuration for all devices, but in a lot of situations, you're going in, you're fine tuning the individual radio, meaning each access point is operating on a locked in channel or they're on an auto channel. If you're going by the group configuration, there's a possibility. That's the question I have to ask. But if you're going on an individual level, then no, it's going to be per AP. So the 1230S is operating with 0 DFS, not all of them. So, but in a group radio configuration, which typically doesn't happen, you kind of want to stay away from auto channel, auto output power when you're in larger deployments. So my initial answer is no. You would have to have all 230Ss or all 220Ss or a mixture of 230Ss and 220Ss. But I'll follow up on that specific question.
All right. Will the devices also include automatic or downloaded updates?
Oh, yeah, definitely. So when a device is registered to the cloud and assigned to a network, one of the first thing it does, it pulls the configurations and then it pulls the latest firmware update. After the initial firmware update, it will go through a schedule. The schedule can be set within the cloud. So yes, it's automatically updating as new firmwares come out. You can set it to stable, previous stable, or even beta. For customers, if you're installing into customers, you want to keep it on stable, obvious. I think that's obvious to everybody. You don't necessarily want to use beta, but yes, it will automatically update.
Perfect. What's a good EnGenius PoE switch to start with to build a system from the ground up? I have 2 EWS 220S radios to start with.
The 220S, so I would go with the ECW 1112FP. Again, that's ECS 1112FP. That's an 802.3 AT compliant switch. So it's a PoE plus switch, 8-port switch, has 4 uplink ports. That's a good switch to start with. I would start there.
Does the AP support standalone cloud hosting?
Standalone cloud hosting. No, I think they're referencing, can I take the cloud management system and install it on maybe like my personal AWS account or on a server? No, it's a true cloud solution. It's not like a hybrid similar to like our EasyMaster solution. Our EasyMaster solution is a software that you can download. It's a free download. You can put that on a server. You can put that on AWS. You're pretty much, you can put it on any, like a virtual server or a virtual machine, and it will operate and manage devices. Whereas this system is a true cloud solution. It works on AWS Lambda, which is serverless system. It's operating with a bunch of different servers. So it allows us to scale really, really high and allows us to be up 24/7 basically on the system. So this is a true cloud solution. So no, you wouldn't be able to do that if I understood the question correctly.
Great. If you add on a premise network controller, does the cloud controller still work?
Yes, 100%. Yeah. So the you're referencing EWS switch, which has a controller built into it. That switch will only manage the on-premise access points. If you have cloud access points on there, the cloud access points will be managed only by cloud. It won't be managed by that particular switch or controller.
Does EnGenius offer a Wi-Fi site survey tool? If yes, is it available in the cloud, or did you already touch base on that already?
I did not touch base on that. Yes, we do. So there's a number of different ways you can do it. If you're a partner with us, there's a thing called Easy Wi-Fi Planner. It's a Wi-Fi planning tool. You know, you always have to go and do your site surveys, but this will allow you to build a bill of materials. It will show, you know, you can draw on your walls, your different types of windows and doors, and it will lay out the access points based off of, you know, what your RSSI settings are, the output power you set, and you can use that within the cloud. You can use a thing called floor plan. You can do the same things within the floor plan view. You can build out the walls and things like that. That falls under the pro license, but yes, you can do it within there as well.
Right. Are there any plans to export spectrum analyzer data?
That actually is a great question. Yes, there is. That is something I believe is in the works. So that is on our roadmap. Well, I'll have to follow up with that one as well. Availability or time frame, I'm not sure when.
Okay, and then there's one more question through the chat. So I wanted to respect everybody's time, as I know we need to move on to the next thing. So I'm going to go ahead and ask this. And then if there are other questions, please feel free to reach out to your Streetwave rep, or I already typed in Brian's email on the chat, and I'll readdress that again as well. So the question is, are there wireless AP options that don't require an Ethernet connection?
That do not require an Ethernet. Yeah, I mean, all devices will work in mesh mode. I think that's the reference there, or the question. All the devices will operate in mesh mode. Now, within the cloud system solution, you would have to have two devices. One device is wired. The other device can be 100% wireless. It just needs to be powered up in some way. But yes, they can. You can set them up in a mesh mode and take down the primary. But then, I mean, what is the purpose of that, I guess? But yeah, they will work in mesh. You can mesh on 2.4. You can mesh on 5 gigahertz. I think that's the question that's being asked. But yeah, it will work in that way, unless I missed the question.
Yep, that was the question, correct.
Yep.
All right, well, I wanted to just thank the participants for joining today and Brian for doing the presentation. So if you are going to stick around for the raffle, please stay on, and I will pass it on to Tina. So again, I wanted to say thank you, everybody.
Yeah, thanks, everybody. Thanks for your time today. I appreciate it. Hope you got something from this webinar, and I appreciate Streetwave, your time in hosting the webinar. I appreciate your time as well. Thanks a lot.
Thank you, everybody. And I left my information on the chat, so please go ahead. Congratulations to the winners. So please contact me directly so we can make sure we get that free AP sent to you. Have a great day.